Hello students. So today we will start with the connections in three-phase system. So basically in three-phase system we have two types of connection. First one is star connection and second one is delta connection. So today I will discuss the star connection for three-phase system. Here this is the diagram for star connection. If the endpoint of all the three phases are connected at a single point, then this connection is termed as star connection. Here it can be drawn like this also, so don't get confused. Remember the basic concept. If the endpoint of all the three phases is connected at a single point, then it is termed as star connection. And this point is called as neutral point. This phase is R, this phase is Y, and this phase is B, and here the resistance is for each phase. Now we have to define some terms. The voltage between a phase and a neutral, this phase R and this neutral N, is termed as VRN, phase voltage. The voltage between these two lines, line R and line Y, is termed as VRY. Similarly, this voltage will be VYN, voltage between Y phase and neutral, and this will be VBN, voltage between B phase and neutral. Clear? Similarly, this voltage will be VYB and VBR, between two lines. So here VRN equal to VYN equal to VBN. All these are named as phase voltage because these voltages are measured between one phase and neutral. So between 2 points, this voltage is called as phase voltage. And VRY, VYB, VBR, these three voltages are termed as line voltages because these voltages are between two lines, line R and line Y. Similarly, line Y and line B, and line B and line R. Now we should use one notation. VRY is equal to VR minus VY. Clear? Or we can write like VRN minus VY. This is your VRY. VRY, voltage between R and Y, is termed as VRN minus VYN. If I will go in the positive direction, like if I will go with this loop, then we can write VRN plus VNY. This will be your VRY. If I will go with this, first of all I will sum this VRN and then VNY. If VYN is taken, then it will be considered as negative. Clear? So this will be your concept, that how the phase voltage or line voltage can be calculated. Now let us draw a phasor diagram for this circuit, and then we will find the relation between the line current and phase current, similarly line voltage and phase voltage. Here let me write, in star connection, in star connection IL is equal to I phase and VL equal to root 3 V phase. So we have to verify these two relationship, and we have to draw the phasor diagram for star connection. So let us proceed further. Let me take this will be your VRN, then VYN will be at 120 degree, VYN, and VBN will be again at 120 degree from VYN. This will be your phasor diagram. Now, what will be the currents? Currents will be lagging nature. Here it will be of lagging nature and with the angle phi. IR, IY, and IB. Here these will be your currents. Here now we have to find VRY. So VRY will be equal to what? VRN minus VYN. VRY equal to what? We have right here. VRY equal to what? VRN minus VYN. So let me take this VYN in the opposite direction. It will be equal to minus VYN in the opposite direction. So combination of these two, VRN and VYN, will provide me the line voltage VRY. Clear? Now tell me one thing. When I am taking this VY in opposite direction, then this whole angle between VRN and VBN, it was 120 degree. Now this angle will get divided in two parts. It will be 60 degree and it also will be 60 degree. Clear? Now this VRY is in the center of this VYN and VRN. So this angle will be what? 30 degree, and again this angle will be what? 30 degree. Clear? Now we have to find the value of VRY. Here you can use parallelogram law. VRY will be equal to VRN square plus VYN square plus 2 VRN VYN cos 60 degree, and here it will be in under root. This is your parallelogram rule. This angle is considered between VRN and VYN. So let me change some here. Let's take VRN equal to VYN equal to VBN equal to V phase, and VRY equal to VYB equal to VBR equal to VL. So put this value. VL will be equal to under root VPH square plus VPH square plus 2 VPH cos 60 is equal to what? 1 by 2. So put the value of cos 60. So this 2 will get cancelled out with this 2. So it will be equal to VPH square plus VPH square plus VPH square. So it will be equal to 3 VPH square. So finally we will get root 3 VPH. It will be equal to VL. So in star connection, the line voltage is equal to root 3 times of phase voltage. Clear? Now again consider this circuit. Here the current IR is flowing. Here the current IY is flowing. Here the current IB is flowing. So what current flowing in line? It is IR. The same current will also flow here in this phase. Here in this phase also the current is IR only. Here in this phase the current is IB only. Here in this phase the current is IY only. So what we can conclude, what we can say, in star connection VL equal to root 3 VPH and IL equal to IPH. The line current will be equal to phase current and line voltage will be equal to root 3 times the phase voltage. Clear? Now we have to find the relation for power, that what will be the value of power. So total power will be equal to what? Total power will be equal to 3 times into phase power. So what is 3 times into phase power? 3 multiplied by VPH IPH cos phi, the power of single phase circuit. So VPH will be what? We have to convert this. This is P phase. Clear? So let me take what will the value of VPH in terms of line voltage. We have just derived the concept. Look here, we have just derived the concept that VL equal to root 3 VPH. So here VPH will be equal to what? VPH will be equal to VL upon root 3. Let me put this value here. 3 multiplied by VL upon root 3 multiplied by, and IPH is equal to what? IL. IPH is equal to what? IL cos phi. So here it will be converted into root 3 VL IL cos phi. This will be your line power. Clear? And what will be the phase power? Phase power was multiplication of power in all 3 phases. Clear? So it is the concept of power. Now let us take a numerical and find the value. This is the question, and we have to calculate the line current, the power factor cos phi, or power factor and the power supply. What we have to remember? We have to remember that in star connection line current will be equal to phase current, and line voltage will be equal to root 3 times of the phase voltage, and phase power will be equal to 3 times of power into single phase, and line power will be equal to root 3 into VL IL cos phi. So it is the concept in star connection. Now we have to solve this question. So first of all, what will be the phase voltage? Vph will be equal to VL by root 3. So what is VL? 400 upon root 3. So you will get 231 volt. This is your phase voltage. Now we have to find Z, impedance of each phase. Each phase is having one inductor and one resistor. So ZPH1, ZPH2 and ZPH3 all will be equal because having the same value. So let me calculate ZPH. ZPH will be equal to what? Under root R square plus XL square. Now it will be equal to R is what? 20 square plus 15 square. So it will be equal to 400 square 400 plus 225. So it will become 625 under root. So value will be 25. So ZPH is equal to 25 ohm. Now the value of current IPH will be equal to what? VPH upon ZPH. VPH is what? 231 volt. 231 volt upon 25. So the value will be 9.24 ampere. Here we know IPH. In star connection, IL is equal to IPH. Therefore, IL will be equal to 9.24 ampere itself. Current in line and phase will be same.